Hello, I'm going to present today how to obtain knowledge on data, visualization perspective using DynetVis. I'm going to introduce to you DynetVis. It's a software to visualize dynamic networks. I'm going to show some functionalities of the software first. Then I'm going to show some examples of patterns and something that we can discover on the data. So for example, here I'm going to open a network. So I just have to select the network, the file. For more information about how is the format, we can click here in information and you can see the file formats and everything that you need. So I'm just gonna open the file here. Okay, now we have in this option those two visions. We can have this temporal vision where the nodes are positioned in these lines and the columns are the timestamps and the ads. So we have some options here. For example, use a force directed layout. You just select the force that you want. Okay, let's say we want a higher force, so we can separate more the nodes. So here we can change the color, we can change the size of the nodes, change the colors of the ads. We can select some colors here, let's say red to green, and we can also change the stroke of the ads so we can see better those ads with the high value. And we also have a coordination with this layout, this temporal layout. So let's say we want to see those two nodes using the Z. So we can see those two nodes here. So we have this interaction based on timestamps. So we know when they connected and why they are so active in the time. But something very important here in this temporal layout is the node ordering. We have approach here that use community. We have those two options here, Louvain and InfoMap. Let's say we use Louvain. So we have those communities divided in some different types of communities. We can even filter in intra edges and inter edges. I'm gonna present here a case study using high school network. This network represents the relation between the students inside that school. Each color here represents a class. There are some classes that are more related to each other. We have the legend here. Those first three classes are related to courses of biology. We can see here in the structure layout that they are more closer to each other than to, for example, this MP, MP1, and P2. There are mathematic courses here. So they are also related to each other, and those two are related to. This is a pattern that we can see in the structure layout. Here we have an option to animate this layout. We can try to see through time. We can change the speed here if it's too fast, so we can see what's going on inside each activity inside each class. Here we have an empty timestamp. We can see this better in the MSV layout, the temporal layout. We can see there is an inactivity. This is because this network don't have activity through night, so we can clearly see the difference between the days and the nights. The colors here is also represent the same classes. So, for example, we can see this is a day activity, the first day activity, the first night, the second day, and so on. And we can easily see that this is a network with 5 days of connection. We can also see some general patterns. For example, we can see this class here, the PSI. Uh, they were in activity until this timestamp in the fourth day. So maybe the student joined the network just later. And we also can see timestamps with low activity here, maybe because some students left the class. We can try to find those type of patterns as well. At last, I just want to show you how to simulate and visualize a dynamic process here. So for example, we select a patient 0 in a timestamp. We select the SIR model and we use a high recovery time. Let's run an epidemiological process. So we can see here the nodes in red are the infected one, and the ads is the timestamp where they infect each other. So we can see the evolution of the simulation here in our website, dynetviz.com. You can download the software. We are still developing at this day. You can see the team that contributed to create this software. And that's it. Thank you all for listening to me today.